right, everybody, so we're starting chapter 2, and we start off with imaginary numbers. So what this first sentence says here is it says, early on you were taught you cannot take the square root of a negative number. And so let me show you what happens when we do that. So if we have our calculator here, and I put in the square root, I'll just use this first one that we have on here, negative 24. When I hit enter on that, what I get is I get an error. But what's important is the other part of the error, which is right here, non-real answer. So I actually have an answer for this, but what happens in your calculator is you get this non-real answer, and it tells you that down here, you're in real mode. So real mode means that we can take something on a number line, and if I had a number line, I can literally look at something and say I have none of something, or I have 1, or I have 2. And if I had 2 of something and I took away 3, well, now I have a negative number. I'm missing 1. And so with an imaginary number, which is what we have right now, it gives us this non-real answer. I'm going to post a video that you can look at that does a good job of explaining what an imaginary number is. But basically, here is the big takeaway. So whenever we have this imaginary number, we use this variable I, and I is defined as the square root of negative 1. It's not the square root of everything, it's just the square root of negative 1. So here we're going to do a little bit of work to simplify these rational numbers down here. So what I have is, if I have 24 and I want to simplify this, we do it exactly the same way that we did with just a regular square root. So I want to find my biggest square numbers. And it might help you if you are struggling with this to write this down. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And if you have this list of these, which you should have already had these memorized, sometimes it makes it a quick little check here. What is the biggest number, what is my biggest squared number up here that can go into 24 and not have anything remaining? And that's going to be 4. 4 times 6 is 24. Well, now I also have this negative 1. So I'm going to add negative 1 onto this list for this first one. So if I have a negative 1, and if I have the square root of 4, this is like saying, if I broke this out, negative 1 times 2 times 2 times 6. Now, where did these numbers come from? Well, the negative 1 comes from the fact that this is negative. This 2 times 2 is my 4 value that's doubled, right? So this is the number I'm going to get to pull out. And I know that 6 stays underneath the radical sign because I cannot break this 6 down into two numbers of the same. So if I looked at this, this is 2 times 3. It's not the same number. I can't pull it out of the radical. So I'm going to pull out the negative 1, and I'm going to pull out the 2. So what I end up with is 2i square root of 6. Now, the I value up here, I is the square root of negative 1. So if I have square root of negative 1 underneath my radical, then I pull it out. So this is my simplified form. Okay, I look over here and I see a 4 again. So I have negative 1, 4, and 10. And 10 is 2 and 5, so I can't pull out 2 of the same number. So, and I know that my 4 value here, this value is 2 times 2. So I'm going to pull out another 2i, and this time 10 is what stays underneath the radical because it can't come out. All right, a couple more here. So negative 75, I'm going to have negative 1, I'm going to have 25, and I'm going to have 3. And I know that 25 is the same as 5 times 5. So I'm going to pull out my 5, and I'm going to pull out my I, and what's left is the square root of 3. Okay, last one. So if I look at 21, I have negative 1, and then the numbers that I can pull out of 21 are 3 and 7. So this does not simplify. So with these other examples up here, I've been able to pull out a perfect square, but I can't pull out a perfect square. So with this one, I pull out my I for my negative 1, and then I have to leave the square root of 21 underneath the radical. Nothing comes out. Okay? So now what's going to happen, and this, hopefully this is not new. You probably saw this in Algebra 2. But now what we're going to do is we're going to deal with some operations involving I, involving this imaginary number. So we already know that if we have one I, if I have one I right here, this is the same as just I. It doesn't simplify, right? And so if I have two i's, that's like saying I have the square root of -1 times the square root of -1. Well, when we have two numbers multiplied together underneath a radical, this simplifies to just -1. Now, with this I cubed, I'm going to break this out a little bit, and I'm going to say, okay, I have I squared times I. So when we did exponent rules, we know that when we're multiplying, we can add the exponents. Well, if I have I squared is -1, and if I have one I, it's just I, so this becomes -I. If I have four of these, it's like saying I squared times I squared. So I would have -1 times -1. So -1 times -1 is a +1. So these are the important values that you need to know. You don't need to memorize them, because if you know that the square root of -1 is I, then you can logic through it like I just did. However, you're going to do this enough that it's probably going to get be pretty easy. Okay, so now watch what happens over here. If I have four of these, I know that this is 1 times 1, so this is I. If I have 6 of them, it's like 3 times 3, so this is going to be -1. And this is going to be -I, and this is going to be 1. So if you look at what I have on the left side, and you look at what I have on the right side, what we notice, the pattern here, is that it repeats every 4. So what I would tell you is that if you would take your exponent and subtract 4 from your exponent, it's always going to give you the value that you're starting with. Now, if you've got a big exponent, sometimes you're going to have to do that more than it. You're not just subtracting, you're going to multiply. I'll show you how to do that. Okay, so here's what we want to do. We want to simplify these expressions. So I have a negative square root times a negative square root. So everything's under the radical. So if I multiply these underneath the radical, then the negatives go away. A negative times a negative is a positive. Now, here's the key. I'm going to do these without a calculator. So if I go over here and I multiply 36 times 16, that's some majorly huge number that then I have to simplify. So what I'm going to do is I'm going to break it down right here. And I know that 36, I'm going to have a 4 and a 9. And then 16, I'm going to put all under 1 because I'm multiplying together. I'm going to have another 4 times 4. So if I'm going to do this one time, but you don't need to do this. So 4 becomes 2 times 2, and 9 becomes 3 times 3. And this is already a pair, so I'm not going to break that down, 4 times 4. And now what you see is I have all of these pairs. I can bring out a 2, I can bring out a 3, and I can bring out a 4. And if I bring those out, I'm going to multiply them all together. So this is 6 times 4, so this is 24. Now, -1 away. There's no negative, there's no I. Sometimes when you do this, you won't have an I either. Okay? So if I look at this, 82. So we know there's a pattern up here. I just want to know, what is this going to simplify to? Well, if I know that every 4 it repeats, if I look at this and I say, okay, if every 4 it repeats, and I know that 4 times 20 is going to be 80, then I'm going to be able to pull out a 4 from this, and what I'm left with is I squared. So if I subtract this, remember up here I said we're going to subtract. If I subtract this 80, and how I got this again is that 4 is going to go into that evenly 20 times, and I have 2 left over, then my value here, this simplifies to just a -1, because I know up here that I squared is -1. All right, so as we look at these, a complex number, so here's kind of our definition, a complex number is going to have an I value in it. And when we have this I value in it, we're going to use the format A plus BI. That's how we're going to write this. So A is the real part, and the real part would be something like a 4. And B is going to be the imaginary part, and that would be something like 3i. So if I had this, I would write my complex number as 4 plus 3i. And it's plus because this is positive. If this was a negative number, then I would have minus 3i. And we can have negative numbers. If you look down here, I have minus 8i. So this is in the format A plus BI. And I know that this is not positive and this is not positive, but it's still A, this is my real part, and this is BI, this is my imaginary part. So this word conjugate is almost like opposite. So if we have a number, I'm going to use that same number, 4 plus 3i. So I have this number, 4 plus 3i. The conjugate of that is going to be 4 minus 3i. And the conjugate of a number means that the A part of this is going to stay the same, but the imaginary part is going to be the opposite. So we're going to have opposite imaginary. Okay? Now, when we rationalize the denominator, if you remember rationalize, we did this all the time with fractions. You want to rationalize the denominator. This means you're going to multiply by the conjugate. All right. So I'll give you an example of that as we get into it. All right. So as we do these operations on here, all we're doing here is we are combining like terms. So I'm distributing this negative through. Because I have this negative here, I'm not foiling. So if I drop all my parentheses, I have 2 minus 5i plus 3 plus 8i. And if we want to write this in the format of A plus BI, I'm going to look at my, my real numbers first. So it would be 5. And then I look at my imaginary numbers, so plus 3i. So all we're doing on this is we are combining like terms. Same thing over here. Because I'm adding, I'm combining like terms. I don't have to distribute everything because this is just a positive 1. So this gives me a negative 5. So 1 minus 6 minus I. Now, you can put negative 1i, but we never put a 1 before a variable, and we're going to kind of treat this like a variable. And so when we do that, we would just drop the 1 and say minus 5i. Okay, here's where it starts getting a little bit different. So when we have this, when we're distributing this I term in, we're going to treat this, like I said, just like a variable. So if I distribute this in, I'm going to get negative 4i. Negative 2 times 2 is negative 4 times I. Now I distribute to the second one. Same thing that we would do if this was just a normal variable. I get plus, because it's positive times positive, 6i squared. Now, here's the thing. We're not done. And we're not done because what we know that this can simplify. And I squared equals negative 1. So what happens is this whole term right here becomes a negative 6. So this is like 6 times negative 1. Well, now I have a real part, negative 6. So I have negative 6 minus 4i. And that's my final answer. So any power of I, other than just I, we're going to get rid of. Okay? All right, let's look at this next part. This next part, I have to simplify these first. So this becomes negative 1 times 9 times 9. So this becomes 9i minus 10i. Because I know that the square root of 100 is 10. I've got the negative, I have to pull it out. So this whole thing simplifies to negative I. All right, now, when we multiply by the conjugate, I don't have two terms up here. So we set up here, we want to get rid of the I in the denominator. So hold on, let me add to this up here. When we rationalize the denominator, we multiply by the conjugate, but what happens if it's just I? That's what we have on number 11. On number 11 here, we have just I. Well, I don't have a conjugate. A conjugate would mean that the second term is positive or negative. So when we rationalize the denominator, what we're really trying to do is eliminate, eliminate I. And if we have just an I, then we're going to multiply the top and the bottom by another I to get I squared, because we know that I squared is -1. So if I go down here, I'm not going to multiply by 2i because I don't care about the 2. I want to get rid of the I, so I'm going to multiply the top and the bottom by I. So when I multiply across the top, I get 3i. When I multiply across the bottom, I get 2i squared. Well, if you remember, that's what I said we're looking up here. So to eliminate the I, we're going to multiply it to get I squared. So this becomes 3i times 2, or divided by 2 times -1. Remember, we know that this I squared is going to equal -1. So now I have an I out of the denominator. I would have this. I don't like to keep the negative down there, so I'm going to make this -3i divided by 2. So let me make a little note here. If it's just I in the denominator, then you want to multiply top and bottom by I. If it's just I in the denominator, which is what we had here, we're going to multiply the top and the bottom by I. That's what I did right here, so that I can get the I squared so that it gets out of the denominator. It's okay to have an I in the numerator. That's okay. It's just like when we have a radical. We can keep the square root sign in the top but not in the bottom. Okay, now this is a perfect example of when we have to use the conjugate. So if this is my imaginary part, I'm going to multiply by the opposite. So 2 plus 3i, whatever I do to the bottom, I have to do to the top. Okay, now this is where it gets a little funky, because what we have here are 2 terms, and the only way to solve this is to FOIL. That's what we have to do. So I'm going to use this space that I have here, and I have 5 plus 4i and 2 plus 3i, and I'm going to FOIL this. So 5 times 2 is 10, 5 times 3i. I go to the middle term, I go to the last term, 12i squared. So when I simplify this, I have 10 plus 23i minus 12. Now I went straight to this minus 12 because at this point you need to see that this I squared is -1. So when I combine all my like terms on the top, I have minus 2 plus 23i. Now this is just my numerator. So all of this work right here is just the numerator. Now on the bottom, this becomes a perfect square. I have 2 minus 3i, 2 plus 3i. So if you remember a shortcut for a perfect square, I multiply the first 2 together, and that's going to give me 4. And then I'm going to multiply the last 2 together, so it's going to be minus 9i squared. Now again, I have this I squared term right here, so we know that this is -1. So when I simplify this whole thing out, I'm going to get -2 plus 23i in the numerator over, this becomes -1 times -9, so positive 9, 13. Okay, so with this last one, I'm going to give you a hint, and then I'm going to pause the video, and I want you to solve it, and then come back and check your answer. So the hint on this is the only thing, if we go back here to our definition of a conjugate, the only thing that is opposite is the imaginary part. The only thing that's opposite is the imaginary part. So before you FOIL this out, this is what I'm multiplying by. -2 minus 3i. top and bottom. Okay, think about what we did over here. The 2 stayed the same in both cases. The only thing that changed is we went from a negative 3i to a positive 3i. So over here, even though this is negative, that doesn't change. The only thing that changes is the imaginary part. So I'm going to pause this video. I'm going to work it out. You do the same and then come back and check your answer. Okay, so I did this on a separate piece of paper, just so that I could have a lot of space to show all the work. So I went over here, foiled the numerator. When I fold the numerator, here's what I got. Then I went over here, did the same thing with the denominator. And remember, because this is a perfect square, I just had to deal with the inside and the outside. And here's my final answer. Okay, come see me if you have questions.